a certain type of cabbage has a mass. Okay, we let X be the mass of a cabbage with mean 1.2 kg and standard deviation 0.2. So we can write X has a normal distribution, mean 1.2 and standard deviation 0.2. Okay, how many will have mass greater than 0.9 kg? So we can write Px greater than 0.9. We draw the graph of Px greater than 0.9 with mean 1.2, and we draw line 0.9. The area is greater than 0.9. We must change X to Z, become Pz greater than 0.9 minus 1.2 over 0.2. We get Pz greater than negative 1.50. Okay, we transfer to Z distribution with mean 0 and 0.9 become negative 1.50. From the graph we can see that negative 0.5 in the left side become 1.5 in the right side. So we can write 1 minus Pz greater than 1.5. We read 1.50 from table. We look at 1.5 in first column and 0.00 in the top row. So the corresponding value is 0.0668. So the answer is 1 minus 0.0668. So the answer is 0.9332. Okay, but the question asks calculate an estimate of how many will have mass greater than 0.9. So 0.9332 we times with 1000. So the answer is 933 cabbage will have mass greater than 0.9 kg. Okay, another question. A farmer rejects 5% of a large quantity of cabbage because they are underweight. Calculate the minimum acceptable weight of a cabbage. Okay, from this information, draw a graph, and we know at the right side the mass of cabbage are large and mean for this distribution is 1.2. So because they are underweight, so we put K on the left side because the area is 0.05. Okay, we write in mathematics equation Px less than or equal to K equal to 0.05. Okay, we change to Z. We get Pz less than or equal to K minus 1.2 over 0.2 equal to 0.05. Okay, look at the condition. The area is 0.05. We can read from the table, but symbol is less than or equal to. We cannot read from the table. So we look at graph Z's distribution and we know we must change to the right side. Okay, K minus 1.2 over 0.2 become negative K minus 1.2 over 0.2. So we change Pz greater than or equal to negative K minus 1.2 over 0.2 equal to 0.005. We can read from table. Okay, from this table we look at alpha. We look at 0.05 and the Z alpha is 1.6449. So we can write P pz greater than or equal to 1.6449 equal to 0.05, and we compare. So we get k minus 1.2 over 0.2 equal to negative 1.6449, and we simplify, we get k equal to 0.87102 and k equal to 0.870 kg or 870 gram. Okay, so the minimum acceptable weight of a cabbage is 0.87 kilogram or 870 gram. Okay, from this question, okay, x be the thickness of a component with mean 0.5 and standard deviation of 0.1. Okay, component reject when the thickness is outside the range of 0.38 cm to 0.41 cm. From this question, we can write that Px less than 0.38 plus Px greater than 0.41. Okay, look at the graph. Okay, we draw x distribution with mean 0.4 and we draw 0.38 and 0.41 and sketch the area less than 0.38 and area greater than 0.41. We change to pz less than 0.38 minus 0.4 over 0.01 plus pz greater than 0.41 minus 0.4 over 0.01. Then we get pz less than negative 2 and pz greater than 1. Okay, we change to z distribution, 0.38 become negative 2, 0.41 become 1, and pz less than negative 2 become pz greater than 2 and pz greater than 1, and read from table. We get 2 is 0.0228 plus 1 is 0.1587 and the answer is 0.1815. So the percentage of the component are rejected is 18.15%. Another question, show that the percentage rejected will be reduced if the mean is changed to 0.395. Okay, we write X has normal distribution 0.395 with variance 0.01 squared, and the question is still the same. Px less than 0.38 plus Px greater than 0.41. Okay, we look at the graph and we change to z distribution and we get pz less than negative 1.5 plus pz greater than 1.5, and look at the graph, we can see that answer is 1.5 and 1.5. We can write as 2pz greater than 1.5, and look at the statistic table and read at 1.5, we get 2 times 0.0668 and the answer is 0.1336. Okay, from the answer we can see that 13.36% component are rejected compared to 18.15%. So we show that the percentage rejected will be reduced when mean is changed to 0.395 cm. Another example, X has normal distribution with mean 40 and variance is sigma squared, and Px greater than 50 equal to 0.1190. Find the value of sigma. So we draw Px greater than 50 equal to 0.1190. Mean is 40 and we draw line 50, and the area Px greater than 50 is 0.1190, and we change to Pz greater than 50 minus 40 over standard deviation equal to 0.1190. 0.1190. Okay, we look at the condition. Okay, we have symbol greater than and the area is 0.1190. So both conditions are suitable for us to see the answer from the table. Okay, from table we look at 0.1190 and we look at the first column, we get 1.1 and the first row 0.08. So we can write Pz greater than 1.18 equal to 0.1190. So we compare, we get 50 minus 40 over standard deviation equal to 1.18 and we get standard deviation equal to 8.47.